In this video, I'll present an example implementation of Automotive SPICE process in StrictDoc tools. Video is divided into three parts. For people in hurry, I start with conclusions, then a few words about ASPICE in general, presentation of what is implemented, some issue presentation of process implementation. I will focus on system architecture, some metadata inheritance linked to Agile with ASPICE, some tricky stakeholder example requirements. Next, I will talk about the StrictDoc itself and in my opinion in comparison to other ALMs like CodeBeamer. All my work is under mid license. You can see it's on my GitHub repository under automotive design model, and also the documentation itself, the output from StrictDoc is hosted on GitHub pages, so you can just access this link and you will be able to see what I present. Okay, so I will start from conclusions and what I've learned from this exercise. I've implemented only a small portion of ASPICE on some trivial examples. I had really a lot of redesigns. I changed a lot of metadata, a lot of traceabilities and so on. And like my conclusion is that you really cannot fully predict the impact of changes that you made to the process. So basically you should test your process before or maybe after you will make an update against some data that you have, some preset, some dummy project. So you should have some requirements, test interfaces, checklist that you can test your process changes against. And then you go through all the steps and see how it really affects your process. And the second thing is when I created first those documents here and the fields for example for requirements, I had really a lot of them. And as you can see here, this is the definition of the requirement here. It started to be really hard to create a new requirement because you need to fill all the metadata here. And then I was experimenting with really reducing the metadata to really to bare minimum that you can have. Do not expect much from engineers that will create those requirements, because if the engineer needs to, before the creation of requirements, to fill like 10 different parameters, then probably he will not make many of those requirements. Yeah, he will tend to create one big requirement, or she will not do it at all. And probably you also will need to adapt many times, because the project changes, the tools are changing, the people are changing, they have different habits, and also the technology is changing. And this results in the changes of process and how the product is developed. So it's very unlikely that you will have one process that will fit all your projects and it will be forever the same. Last point, some brief conclusions about StrictDoc. I think that the method itself for a tool, because this is like text-based tool for the requirements development, is really good idea. Why? Because in case that you do not have many dedicated system engineers, in the end, software engineers that often are making the requirements at high level, like the system requirements. They're working with system requirements. They're always making the software requirements, and what they like to do is just to use their text editor and just simply write it, write like a code. And this is really kind of effective, especially if there will be tooling for the Visual Studio Code, for example, to highlight the syntax and so on. And the second thing, so especially if you are doing software or you are a software-focused company, it's maybe worth considering having a tool like this. Yeah, because you then have all the code and all the requirements and documentation really in single or two repositories. And also you leveraging the review process for a code, and basically you are making the approval process, the baselining process, and the review process of the requirements the same as for code. And this is really, I think, something that just comes automatically if you have good software process to the requirements. And when looking at other ALM tools, really they are lacking this. And this is just, already there for code anyway. Yeah, and lastly, I would say that it is very easy to generate some reports to tailor the tool to your needs, because this is Python and this is open source. But bear in mind that this is like heavy development. Yeah, there are new commits basically every day, but this is good, I would say. There's quite few contributors, hopefully it will go well. Okay, this is all about the conclusions. Now I will briefly go through the SPICE itself. So I will make a brief 2-minute explanation of what it is, why it is, go through the most important points. So how to describe this SPICE? Basically, it defines the process that should be implemented in the project and that company should implement. So this is like a model for all the processes that company should have. It describes most of the activities like contract agreement, bug, risks, release, and the development activities for software, electrical system, mechanical development. A process itself is divided into groups, common activities, like you can see here on the picture, probably well-known V model. Each of group has set of specific requirements that needs to be fulfilled. Those are base practices. And base practices basically describes engineering work. They are most important part of the SPICE, I would say, and this is level 1. So examples of this base practices could be, we go here to software architecture design, for example. There are base practice like define interfaces of software elements. Yeah, so here it is said that the work product called software architecture should define you the interfaces for software elements, whatever it means interface and whatever it means element, because it is not defined. And for C it will be probably global variable or a function, not non-static function. Yeah. But for other type of code, it can be something different. Same for elements, the same for units. SPICE is very generic because you cannot do one process that will fit all. And next, we have some set of generic practices. Base practices are basically each process have its own. But for generic practices, there are 5 generic practices for all the processes, and they are the same for all the processes. And basically, generic practices relates to the process organization and measurement. They try to answer the question: is engineering know what should do and how it should do it? And it tries also to answer the question: is the engineering team really doing the base practice right and in time? And this is SPICE level 2 basically. So if you have SPICE level 2, if you don't have SPICE level 2, you can do a perfectly fine product, but there will be chaos in the development, during the development, and there will be, and the development itself will be unpredictable in time. Next, there is level 3. So there is also a definition of standard and deployed process. You can have, and the idea behind it is that you can have one generic process in company, and this process will be deployed per each project with some adaptations that is called tailoring for the project specific needs. So this is level 3. So it's more like on the organizational level than on the project level. And there are also some other levels, but no one cares. So, are there any advantages of SPICE? I would say, this is my opinion, but some steps are makes less or more sense depending on the project scales and tools that you use, And there are no agreement even in this SPICE community about some topics, but I will just focus on the advantages here. So it is good that there is a common language between OEMs and tier 1s, tier 2s. So you can always change the work and feel the same. Also, most of the best practices, generic practices, and processes really have a lot of sense. And if you see it differently, then maybe consider that you just do not understand what SPICE best practices is requesting from you, or if this generic practices or base practice is costly, probably not sticking to it will cost you more in bugs or cost of maintenance or cost of reuse for the other projects. Now I will go to the third part, the presentation of the project itself. And basically we have only part of the V model, left side, and only really like high-level design. Detailed designs are missing here in purpose, kind of. More often they are really part of the code itself. So it is not that costly to maintain them. And here is described the item boundary diagram. So basically what we have here is we have an ECU, a drive motor ECU. The functionality is the ECU monitors autonomous drive string parameters based on inputs from ADAS and BCM ECUs. So this is like some FUSA guard for if the ADAS behaves correctly. The MCU itself has a set of functionalities, some FUSA checks, some application for ADAS, some application for trajectory, some communication stack, UDS, also secure boot. It is functional safety related. It is cybersecurity related. We've got level 3. And what I propose in this system architecture is to break the ECU itself into features and focus on the features mostly. This is because what you really want to deliver is the features to the customer, not the interfaces or components. And yeah, that's why the features are first here. Thinking what are the core features. So for example, here you can see the operating system is missing because no one cares if there is operating system or not. Like customer does not care about it. He cares about if the communication is working correctly, if there is UDS, if the applications that he really needs are there. And what are the key features here? This is CAN 1, CAN 2, lean interface. MCU itself I listed here. Some enclosure and MCU features. So ADAS application, once more CAN stack, UDS stack, lean stack, bootloader, secure update. So secure boot, secure update. And below each of these features, you can see that there is release what is expected, and there is variant in which it is. Yeah. So both of those fields are items here in the project itself, and they are also configured with StrictDoc. What we can see here is I assigned the AC level and the CAL level to the component. This is because I didn't want to enforce on the developers, select for each of the requirement the cal level and the ASIL level. For 90% of the requirements, you have the same level that really sticks to the component itself. So why not to inherit it? And current version of StrictDoc doesn't have this feature to really take the value from upstream component and place it here. But maybe this is like good exercise to see if it is easy to extend the capability of the StrictDoc by yourself. But this is how I imagine it, that those fields could be inherited by default. And if they need to be different, then it is up to the developer to change it. Next, few words about the traceability itself, the traceability of the requirements. So there are different views here, and you can see how some requirements are linked to the variants, to upstream requirements. What is lacking is like the dynamic filters here. Okay, now what I want to show you is some example of top-level requirements. It's sometimes the case that you have a requirement like this from your OEM or from your customer, and how to approach it. Should we now like split take the norm and just requirement by requirement, put it in our specifications and add the test? I would say yes, because there is no other way to really prove that you are complying to it, especially if this is like CAN specification. But what you should consider is that if you have a requirement like this, move it to another project, all the specification, the architectures, detailed designs, the code. It will be easier to have it like out of context and then just link it here in your core project. It will be easier than to reuse this part and this specification. Next, I would like to say about some very detailed requirements. Sometimes it's the case that you get from your customer very detailed requirement, and what then to do. Here's one example, maybe not that detailed, but anyway, time for wake up signal shall be measured by microcontroller hardware timer. And now is the question, does it make sense to create system requirement that will basically say the same thing? Or maybe it makes more sense just directly go to electrical or software requirements and there create some downstreams. Or both approaches has some advantages and disadvantages. This approach without blindly copying the requirements for sure is less work. Okay, now I will switch to VSCode and I will create some example requirement. But first, what tools I'm using. Currently, StrictDoc does not have any graphic user interface, so I'm using Visual Studio Code. From plugins, what I have is Live Server. This plugin enables me to have a automatical update of web page that is generated from StrictDoc. So when I change anything here, I just click Ctrl-Shift-B for a custom build command, and you can see here below the StrictDoc is building, checking all the requirements that I defined here. And here is example one warning that one of requirement is missing a parent requirement. And after it's built, web page is automatically updated, so I can see something new. So the build command I've defined here in just JSON as a strict export dot. I have also some custom snippets, so I do not have to write the requirement. So to create a new requirement, I just hit Control space, type the name of the snippet, SW, hit enter, and now it's time to generate some ID. It can be number or it can be some name. I will create a new requirement for lean driver. Verification methods can be like integration testing. Here you can see that the fields can be different types. I will say more about how I've defined those fields here later on. And for an upstream, let us only depend on the system architecture element. And lastly, I will fill some statement like lean driver shall support software emulated reward. Okay, yeah, and here we have a new requirement. What took me a lot of time is this grammar that is really strict. So you have to have only one enter here. You can't have spaces. Also, all the fields have to be in the same order as it is defined here, because on the top, first you are defining your document title and how it is typed. Then you are defining a grammar for this document. This means that in this document you can only have tags that are defined here, and those tags can only have fields that are defined below. Fields can have title and type. There are a few types like string, single choice, so kind of enum, and others, always described in documentation. And also some fields are required, others are not, and here you are defining it. Okay, so let us see if the requirement has a correct format. It mentioned that there are two with the same UID. Okay, I will update the UID. Build it once again. As you can see, the build takes some time, and even for this quite small example, I'm not sure how it scales up. Yeah, it built it. Let us check the web page. Yeah, we have new requirement here, and we can navigate and see. Yeah, that is linked to the system architecture element, and also in this system architecture element there is this new requirement added here. Regarding improvement, the tool is still lacking a lot of features. Hopefully new features will be in the next releases. And regarding the maintenance in general, I think that for really big projects, probably there will be issues like navigating over the document, especially without like help and some plugin for Visual Studio Code. It will be difficult to navigate here. Also, sometimes you have really like stupid error like this, and it will complain, and it will not compile. As you can see, a lot of errors was generated. Good that it kind of shows the line in which it has an issue, and actually the explanation of error is not that bad, but it sometimes takes time until you get what is really the issue. Okay, so basically it's all for this video. If you would like to see more of this, let me know in the comments maybe. If you would like to see a review of other ALM tool, let me know. If you would like to see maybe another work products like software architecture or something else from the SPICE, how it can be implemented here in StrictDoc,
Also, please leave a comment or contact me. Thanks for watching.